Okay, next we're going to learn about taking measurements for alternating current, AC as we refer to it. And on a boat, that can come from shore power, or it could be a DC to AC inverter installed somewhere on the boat, or it could be coming from an AC generator installed on the boat. So it's nice to be able to measure and see what's going on. Our concerns are with AC voltage, AC frequency, and perhaps AC amperage. So we're going to use this Sperry meter to measure all three of those things. This meter has that capability. Now right now I've got the meter set to the V scale, so I'm going to be measuring AC volts. It's indicated by the V with the wavy line over it. And the wavy line represents what is known as a sine wave. If we were to look at AC current on an oscilloscope tool, you could actually see a visual picture of the alternating current sine wave in action. Okay, so we're plugged into a pretty typical 15 amp wall outlet receptacle, and we've got three leads, our hot, neutral, and ground. The hot lead is designated by the shorter of the two vertical strips. The neutral is the longer of the two vertical strips, and a ground lead with a three-prong plug would be the nearly circular termination point there. We only need the hot and the neutral to pick up a voltage reading, which I have right now. I'm measuring 119.4 volts here, which is quite normal, even though it's all rated at 120 volts nominally. Anything plus or minus about 10% of that is considered acceptable here in the United States. It will vary throughout the day depending on how many people are actually pulling current from the grid in a given neighborhood or area. So 119.4 is perfectly fine at this point right here. As far as frequency goes, frequency is pretty important that it be within about plus or minus a maximum of 5%. So here in the United States we run at 60 Hertz, and that's the frequency here, 60 cycles per second. Most of the rest of the world runs at 50 Hertz. So we are a little bit different in that regard. But here in the United States and Canada, it's nominal 120 volts, 60 Hertz. So we're going to measure the Hertz simply by hitting a button on this particular meter that's bringing us in at 59.96 cycles per second, which is pretty darn good. I mean, it's as close to the 60 Hertz as you're going to get, and certainly well within any acceptable tolerance. So we've measured both voltage and frequency. Frequency on a boat, it's a good idea to check it with a generator running, because if there's any sort of an RPM issue with a generator, that's where you'd be likely to get a high or a low voltage reading, or a low frequency reading. It'll change pretty dramatically with very small variations in engine RPM on an AC generator. As far as residential or utility delivered power, I have never ever been able to measure it where it was out of sync. I mean, it's always very close to that 60 Hertz. The power companies do a great job of controlling that in their power delivery systems. So, AC volts, AC frequency, we've got it all right here. And there we are, back to the volts, 119.7, holding pretty steady.